Hi, I'm Kristin, and today I'm presenting a paper describing an 18-month ethnography of timber framing at a tiny house construction program in western Washington state. This case exposes the intricate ongoing processes whereby people learn to imagine, create, and maintain living materials, an area of growing significance to HCI scholarship on new materials, sustainable design, and digital fabrication. Over the past 2 decades, HCI scholars have begun to examine the role of materials that grow, learn, change, and regenerate. In this context, designers face key limitations around their means of dealing with these materials as they change form, seeking out new tools and procedures for working with them. In addition to efforts to program and control design materials, in what follows, I draw on almost 2 years of field work, building 3 timber frame tiny houses in a woodworking trade school where materials are neither discrete nor passive things to be worked on. Here, material qualities are performed. Taking lessons from the Woodshop, I'll outline some of these performative qualities and the way they expand HCI's approaches to materials. Interaction design increasingly entails working with living materials, design resources that actively change over time and bring their own histories to the design encounter. Among these are computational composites, smart and transitive materials that change, and organic or carbon-based materials like bacteria, algae, and wood. Scholarship in long-term design, sustainability, and repair has already drawn attention to the natural resource limits that underpin such developments in technology. In parallel, HCI scholars continue to explore materials' capacities for action. The recent materialist turn has emphasized the distributed and contingent nature of material agency, proposing terms like propensities or proclivities as preferable to maybe properties for describing dynamic materials. We extend this work with nuance and detail as to how exactly material properties emerge in a situated design practice that takes the limits of natural resources seriously. Drawing together these strands of literature, the case of timber framing animates the relationships between changing material properties and ecological engagements well beyond the materials at hand. Timber framing is a craft building construction method using large wood timbers, which I'll also call members, linked together with joinery, which is the handwork of shaping and assembling wood pieces to fit each other into a structural whole. Using Jean Lave's tradition of critical ethnographic practice through apprenticeship-led fieldwork, I've been participating in woodworking intensives at a trade school in Port Townsend, a small Victorian town in western Washington known for its crafts community, particularly woodworking and boat building. At the school, I participated in timber framing 3 small buildings, collected hundreds of photos, videos, and sketches, and had informal conversations with around 20 builders in the area, including about 10 hours of in-depth interviews with 8 key informants. As a research team, we've analyzed these materials with iterative rounds of annotation, memoing, and discussion to develop the themes that I present now. These themes, which I present as characteristics or qualities of living materials, are deeply intertwined and not discrete or mutually exclusive. Today, I'm just going to focus on a few of them, but you can read more in the paper. My woodworking instructors, whom I'm going to call Stan, James, and Mike, said they chose timber framing construction methods in part because they can use less material and form a structure that lasts longer than it took the component trees to grow, a stewardship commitment informed in part by the disappearance of old-growth tree stands in the Northwest United States. In the Woodshop, we began to learn how a material's life prior to the design encounter provides clues to its past and how to account for and navigate past damages to finite resources. We noted how markings like knots form defensive traces, or marks of past hardships evidenced by irregularities in the wood's grain that expand and remake the wood in the present, shaping the wood's current strength and flexibility and offering clues as to how that piece will behave in the future. A knot like this one, for example, evidences grain growing around a past disruption in the wood's growth, like a branch that broke off or a disease or infection. Once it's been cut and milled for human use, these past vulnerabilities become pertinent once again. We learn to read the knots for potential changes, such as whether it's likely to work its way out of the timber and create a weakness. For knots that appeared in a critical area of the wood, like this one, the instructors urged us to place them in visible areas of the interior framing that were not directly load-bearing, but that future inhabitants could still see and interact with, watching the knot and the grain change over time. So knots not only provide a glimpse of adversities, the way the tree grew around past disruptions and damage, they also helped us deploy past hardships and material limitations in a generative manner, turning them from structural weaknesses into openings for inhabitants to connect with the tree's past and future. This attention suggests opportunities for adjusting to idiosyncrasies of living material by inviting technologists to use a material's traces of difficulties and resistances as a means of refiguring and growth. By learning to continuously identify changes in wood like a knot that may break loose later, we found living materials produce what we call legible textures, physical patterns that reveal something about the material's past as well as its future to be redeployed by the attentive builder. We paid close attention to the grain as a record of how the tree grew and how it might continue to change when worked into a different form and placed in a particular part of the structure. Considering each piece's history and the still emergent implications of that history, each time tool met wood, and each time we set a member in place. Even after the wood is cut, the grain continues to shift, expand, and warp with hyperlocal moisture, temperature, and pressure changes. Attending to legible textures, like the ones you see here, the tight, close grain, suggests bringing a constant, deliberate attention to the shifting behavior and appearance of materials in relation to their specific local placement. Vital decay refers to the complex non-human influences that builders work with while connecting timber members, such as the forces of gravity, weather, and aging that shift and degenerate wood joinery over time. In the woodshop, we learned that a tight, well-executed joint can act as a durable structural component for many decades. The process of making this is slow and painstaking. Joinery instructor Mike, who's been building musical instruments and furniture for over a decade, introduced this tuss tenon, which is a style of joint he said is often used in furniture and beds and other pieces of furniture that have to withstand repeat daily racking forces. With this kind of tuss tenon, there are two pieces of the same wood that interlock at a 90-degree angle, with a hole through the horizontal piece that has a wedge down in it. So as the joint kind of degrades and shifts and becomes loose over time, gravity actually pulls the wedge down and keeps it snug. My classmate and now a professional cabinet maker, Ralph, described trying to wrangle durability out of these kinds of uncontrollable future wear as a kind of four-dimensional thinking. He told me, I think builders and craftsmen, especially the more experienced they become, you have to think about this two-dimensional drawing in a four-dimensional world, and then add weather, add time, add extra materials, and then the more experienced you are, the better you are at thinking, okay, where could this go wrong? What are the potentials here? So in the woodshop, the forces of gravity, daily human wear, and weather that lead to decay became a kind of co-designers, extending design into the future and out of the reach of human control. Developing as a woodworker in this tradition means building durability where possible, but learning from experience what you can't control, living in this kind of balance between skillful anticipation and letting go. Vital decay means structures by even the most skilled builders can eventually wear out from friction, rot, or any number of accidents. But what happens when the replacement materials are no longer easily available? The second week in the woodshop, we set out to build the top and bottom plates of the houses. These are long horizontal timbers that hold the walls together and should be several yards or meters long. Because we didn't have the nearly 20-foot boards that we needed, we started using these kinds of scarf joints, and they became really central to our construction scheme. They allow you to make really long stretches of timber out of shorter pieces. And this type of joint is also used to repair wood that's been rotted out over the years. So if you ever go to Northern Europe and see the stave churches or really old temples in Japan and you look closely, you'll see joints like this used. Cutting and replacing damaged wood using a scarf joint meant not only drawing attention to the scarcity of natural resources, but embracing opportunities for performing that scarcity. In this way, resource scarcity did not necessarily represent something to fix or avoid, but make visible through a process called announcing the joint, where we kind of round the edges so that as the joint decays over time and shifts out of place, it draws attention to that process. Here we begin to see techniques like announcing the joint and the scarf joint itself as techniques for accounting for the scarcity of long timbers while celebrating their aesthetic form, and drawing attention to how human building practices have produced that scarcity. Although readers familiar with woodworking practice may find the insights about knots, wood grain, and so on obvious, I argue that HCI contends with a growing range of living materials and fabrication techniques in a context of natural resource scarcity. And as such, designers need to reconsider our engagements with traces of provenance, reparation, and decay. It's these engagements with histories of encounter and broader ecologies that our lessons highlight for design practice. Working with legible textures and defensive traces, for example, draws attention to the vibrant agencies that flow through materials and can be engaged as design resources. In the Woodshop, the wood is an active co-designer with a rich life of its own, to be appreciated, understood, and grappled with, not a latent passive resource awaiting encounter with a human designer or a machine control. We also see non-human materials appreciated as having life cycles bound up with our own. Instead of treating nature as somehow out there, waiting to be mined for raw materials or models of biological processes, like in techniques like biomimesis, in the Woodshop, we see tactics that grapple directly with the meeting points of ecological and fabrication processes. The vital decay and performative scarcity we found while working with wood invite approaches to technology development that recognize nature and technology as mutually constituted. HCI's long attended to how computational tools and systems are made of components sourced from a variety of regions. In the Woodshop, we saw sourcing in action in the frictions between the liveliness of young, kiln-dried timbers and building methods that actually work best with disappearing old growth. Timber framing methods provided pathways for countering excessive resource extraction, making stewardship a central engagement emerging from the tiny house building process. How might HCI take up similar stewardship commitments to not use more materials than the earth can regenerate, a concern for broader material flows? In addition to paying attention to supply chains, we need ways of examining and situating design activities in terms of the finite resources that sustain them and the silent stakeholders of our extractive processes. While on the surface, the materials common to technology development may not appear to be living in the same way wood is, like carbon-based and organically, we can trace every material we use back to an extractive process somewhere, not least in the energy sources that keep code alive, data stored, and devices powered on. Design work exploring material recuperation processes involves locating opportunities for offsetting or repairing these kinds of broader flows and extractive relationships, a process that feminist technology scholar Donna Haraway calls making with or sympoiesis. Just as we saw in building a house that should last longer than it took the component trees to grow, designers can orient technology development around the generative tensions between the survival needs of humans, like housing, and the other species on which our lives and livelihoods depend. Forces of wear and decay might look different at the scale of devices from which HCI has operated for decades, and that of interactive environments and buildings. Paying attention to how forces of wear and decay are treated at the level of a building versus a device or algorithm reveals important assumptions about where the scope of design work ends. When the artifact or interaction breaks, is overwritten by a new version, or otherwise rendered obsolete from the designer's perspective. This view insists on working through material histories and recognizing that the human's intervention is a temporary and modest collaboration situated in a much longer biography, shifting our view of the designer's task to that of negotiating different material histories and local forces of dissolution. Like announcing the joint that's eventually going to move out of alignment, designers and fabrication researchers might re-examine the possibilities for computational composites and new property-changing materials that can turn the glitches and flickers of electronic decay into meaningful glimpses of the broader ebb and flow of computational materials and their life cycles. Through this work, we also begin to see material properties as temporary, as sites for momentarily holding together a relationship between a material and its meaning in a situated fabrication practice. In doing so, HCI gains opportunities to read properties as prototypes of these relationships, open to reworking. We use prototyping here to denote the tenuous and temporary alignments between material and meaning, explorations into what properties might be for now and in this particular arrangement. Attending to properties as situated prototypes of what might be instead of universal, permanent, and impressed upon material opens new pathways to explore and rework taken for granted properties and material behaviors like conductivity, self-healing, and flexibility. This points towards the value of design tools and techniques for speculative materials prototyping, for defamiliarizing taken for granted material properties anew. Using timber framing as a lens, I've shown how centering the living qualities of materials, grappling with materials as non-human design collaborators, decenters designers and situates them in longer material histories that extend from traces of past encounters into future forms that are just outside of our control. In the Woodshop, we learn how design activity takes place alongside and through forces of decay and resurgence where new fabrication and resource scarcity meet. highlighting interrelated characteristics of living materials that interrogate contemporary design practice, like rapid prototyping and so on. We've also learned that cultivating a design practice with these living material characteristics requires multiple methodological reorientations. The first is a move away from treating materials as passively awaiting designer intervention in order to see agency in action. Looking more closely, we find materials have their own lives that extend before and after the design encounter. In this approach, materials and non-human forces become active collaborators in design, and the human designer's touch is just one of many important meeting points in that material's historically grounded perspective. Second is a move away from treating nature as somehow separate from HCI practices as a boundless source of raw materials and fabrication models, instead turning towards the messy intersections of ecological and industrial processes. Lastly, this work expands a program of work on computational composites and digital materials within HCI by exploring properties as temporary alignments between material proclivities, tools, and meanings, rather than a kind of fixed attribute of the material to be manipulated. The designer's task, then, is to work alongside living materials, exploring their possibilities and crafting more sustainable relationships in partnership with our non-human collaborators. And I have some future work coming out in Limits in a few weeks, and that's already posted online if you're interested, but I'm out of time, so I'd like to stop here and thank everyone.
Hi, thanks, Kristin. I'm Dan Lockton from Carnegie Mellon. It was really interesting to see, I guess, such kind of deep practice knowledge then being kind of compared to something else. Like it's like the implications for HCI in a more interesting sense than just implications. I think were really good to hear. I suppose one of the things that came to mind is like so you kind of started to get towards at the end when you were discussing it was how some of the concepts like might transfer. So there's obviously the question of working with materials or working with more than human actors in a sense in that way. But are there, like, I mean, concepts like knots, for example, or decay or different types of joints, like what does, if you were going to transfer that or transpose that into HCI in a non-material sense, like what does it mean? Like what, did you see parallels? Like what does a knot mean in interface design? What is the grain of digital material? Like, is there anything there that you kind of got towards?
Yeah, I think there is some connection with like some of the work that's gone on in seamful or seamless design, for example. But I think these are more like analogies than kind of directly transferable, properties or something like that.
I just wonder whether, for a designer, whether there's some parallel in the process. Like if you're working with wood and you're noticing these things and thinking, okay, I'm going to have to anticipate that this is going to need something different, or we're going to need to treat this differently. Is that, like, those parallels seem quite similar in terms of process? Like, I don't know, maybe they're not. I just...
I guess it depends on your design practice.
Yeah. Cool, thank you.
Yeah, you're welcome. Do you want to connect? Yeah.
Hello.
Hi, Nadia.
This is a fast question. I'm Nadia from University of Washington. And my question is more I seek advice, perhaps. It's a very thoughtful and long-lasting engagement that you had that has a lot of great recommendations in this space. Although, at times, people can look at work that is careful and considers nature in the way that you have and think that it is twee or something that is only available to people who have the benefit of time or money to engage in these kinds of exercises. And so if there are people that make an argument that at the end, when you consider all costs, that this is actually better, and say we were in such an argument right now and you had to give a rapid takedown of someone who's like, why would we all just be people in Portlandia? That's dumb.
I'm sorry, I didn't hear the last bit.
I was just saying, like, imagine if I were antagonistic and questioning the validity of the amount of time that you take and the care that you take in engaging with materials. What are the arguments that you would give to someone who's not going to carefully consider what you say next as to why they're wrong?
I guess I would probably steer away from telling people they're wrong on things to begin with. But yeah, again, it's just a different kind of design practice. And I think there are room, I mean, I think I mentioned Donna Haraway, so I really believe in situated knowledges and that there are values in doing things and having multiple relationships to materials. And my goal here is in presenting an alternative rather than an either or necessarily. But I have certainly a sympathy towards this kind of relationship to materials, and one that, yeah, maybe slows down a little bit and sees the broader ecological implications rather than focusing on speed or that kind of thing, like really, yeah, thinking more carefully about where everything comes from. But yeah, everyone has their own ways of doing things, and this is a complement.